Hey, what's up people? I'm Paul Myers and I'm making a game called Bolero Tactics. It's an adventure game and a turn-based strategy game, sort of like a mix between a Final Fantasy Tactics and like a retro 2D Zelda. For today's devlog, I wanted to go over two topics. The first will just be a quick rundown of how development has been going over the past year and like a little update for how it's been going more recently. The second topic will be a deeper dive into how I accomplished the rotating world effect, similar to like something you'd see in an Animal Crossing game. So, to talk about the state of development, I'll start with the beginning of 2020. What I said at that time was that I wanted to get out a good vertical slice demo that was going to like demonstrate all the core elements of gameplay, plus just like get across the atmosphere I wanted to go for, and I wanted to release that by the end of January. That didn't happen because over the course of that January, I basically learned that for the scope of what I wanted to make, it was going to take a lot more effort to get everything just like polished and put together to show you. So for the rest of the year, I basically made it so that all the different gameplay elements, you know, between battling in the turn-based strategy engine, plus exploring the world in the adventure game mode, and I also made a pretty robust cutscene engine, and I had to make it so that all three of those modes could flow seamlessly between each other in any combination. And that's, for the most part, accomplished at this point. And plus, I've also spent a lot of time this year making just, you know, a bunch of different art assets, trying to make the game look more legit. Over the past month, you know, it's been mostly quality of life improvement stuff, making the game just more fun, smoother to play. And also I took the little detour in making that rotating world effect that's going to be active during the adventure game mode, where you're just exploring, talking to NPCs, and solving puzzles. So I knew from the start that in order to get the rotating world effect, it would need to be some kind of illusion, like how I'm doing the entire level out of two-dimensional sprites, because it is a 2D engine. So I just have a bunch of 2D textures that are rectangles, and I need to make a three-dimensional cylindrical shape out of these two-dimensional sprites. You know, if I was in a 3D engine, I suppose I could just place them in space at certain positions, give them some sort of angle of rotation, place them in the correct spot, point the camera at it. There, I'm done. In my situation though, in my 2D engine, I need to make some kind of framework to think about this entire problem that's sort of abstract in the first place. So I drew a lot of diagrams. The one I settled on that was the most useful was a sort of side view. Alright, so here is how you could picture the level from the side. You have your little character standing here, and the camera is pointing at them directly. So each of these tiles actually represents a lateral row of the level, and the way it is oriented has to do with its actual angle with relation to the line of sight. So this level, this tile here, this is the angle that we're paying attention to. The tile at the top of this quarter circle is perfectly parallel to the camera, so that means we're actually not even going to see it. And the row at the bottom is perpendicular to the line of sight, so we're actually going to see the entire tile, and it's going to appear as a square to us. So now I'll actually frame how the level is structured. So let's say this cube is what the level looks like. The way I have to think about it to get this effect to work is I actually have to split the cube into cross sections, like so. And let's see, it looks like we have 6 cross sections in this level. And in my code I actually call them depths. The way the program is going to execute this illusion of making this cube into a cylinder is it's going to loop through each of these depths and find their proper position and scale. I should say this diagram is how we're imagining the level to look in our framework, but this is actually how it looks in-game. So on the left here, you see how we've split our level up into these depths, which go, the first one is closest to us, and the last one is furthest away from the camera. And the diagram on the right shows the cylindrical shape we want to get towards. Each of these tiles along the arc of the circle actually corresponds to one of the depths. Now that we have a frame of reference to think about our problem, let's set up the parameters. So to orient our level in the shape of the cylinder, it needs a radius, right? So let's decide on some arbitrary radius for our cylinder. From that radius, we can actually also calculate how many depths are going to go into this quarter of the cylinder. Because with a tiny radius, you know, your character will be here, and you know, it could just be 3 tiles that make up this cylinder. And with a giant radius, like this one, it looks like there's 8 here. That actually is using the radius to calculate the arc length. And that arc length is basically telling us how many depths are going to be within this quarter of the circle, from 0 degrees to 90 degrees. So now that we have the radius and we have the arc length, we can assign a corresponding angle to each of the depths in the level. And just visually, I mean, I'll skip the trig for you, but this one looks like it's about 60 degrees, this one's going to be 85 degrees. We assign an angle to each of the depths. In the end, we want to actually move every object within the level to the proper place to make this illusion happen. So we need to actually split these depths into rows, which is, I guess, splitting them by height. It's kind of crude, but you can see we've split each of the depths of the level into different rows organized by heights. So it looks like a big grid of planks, basically. And so as the algorithm loops through the depths, it loops through each depth's height. So it's basically the smallest unit we're dealing with is a row of the level. I know I want to move all of these rows to a specific location to make this illusion happen, but I found it easier to move them each from the same location, which might be considered like the origin. So that origin I chose to move everything away from in a relation was the position at 0 degrees. So I took all of these rows in the entire level, all of these, and I moved each of them to the screen position that corresponds with where a row would be at 0 degrees. And this is what that looks like in the game. Then the next step was moving each row to the proper position. And that involved a lot of trig, and it also uses both the height coordinate of the row, each row, and also this is the y coordinate in my game. Use trig using the y, the h, and the whatever the theta angle was to figure out the position on the screen. And this is what it looks like after that stage. Each row is not properly scaled, but at least it's positioned in the right place. So now the third and final step is scaling each of these rows to make this illusion happen. The scale of the row actually also depends on height. For instance, if there's a tile all the way out up here above the player, it will actually appear longer to the viewer as opposed to a tile all the way down here towards the origin, because all the tiles in the level at the origin, they have basically 0 length. So to figure out the scale, I used a trigonometric function. It's basically this component of the quarter circle, and since the scale here, wherever the player is, the scale of that tile needs to be 1. This scale of the tile is 0 because it's invisible, it's parallel to the viewing angle. The scale here needs to be whatever the scale needs to be to make the sprite appear as a square to you. And that ended up being a little less than 2. So after applying each of these different scales that are associated with the angle of the depth, and then also adding another scale, which is proportional to the height of whatever row we're looking at in relation to wherever the player's standing. Because where the player's standing, the modifier is 1. At height 0, the modifier is making the length of the sprite approach 0, so it's a very low number. You can see in this image what it looks like when we're rendering a sprite that's much higher up relative to the player. So that's basically it. These are the steps that I take to make the basically cylindrical rotating world effect. To get the motion of the effect, basically I recalculate all of this every frame as the player is moving around the world. It took a little bit of optimization. The first couple drafts of this function, the game ran very terribly. I've now gotten it to a point where it's 60 frames per second, and that actually involved me structuring the level within the actual Godot engine hierarchically, so that the algorithm doesn't actually need to visit every tile. It can just address an entire row of tiles at once, change their scale. They all change scale visually. After I figured out how to orient each of the level tiles, there was a little bonus problem was dealing with the level objects, like lampposts and the well, which each already had their own crazy little function for how they would change shape when the perspective was shifting. So I basically had to adapt each of those functions to basically you feed in an angle and then this is how it looks at that angle. And those are also calculated each frame as the player moves. At this point, it works pretty good. I really want it to be in a better state by the time I release the game, because there are some things that I had to cut to actually keep the game running at 60 frames per second. You know, the game's not winning any awards for visual fidelity, so I really need to figure out a way to just get the game running at a smooth 60 upon release. You know, what I've heard is that you don't want to worry too much about optimization this early, but this algorithm is so taxing, I figure I should probably address it as I'm making it now, because I don't want to build a bunch of stuff on top of it and then it'll be really hard to change it later. Thank you so much for sticking around to the end. Make sure to follow me on Twitter, and also hit up my Twitch page, because I think I'm going to be streaming in the pretty near future. I did say I was going to in the last video, but I actually have more concrete plans and I'm going to be posting about it pretty soon, so stay tuned to that. I'll be back with another video next month, or sooner if I, feel like it. So, see you later.